Okay, I'm going to have a wee quick look through the section test here. So number one, which of the following is f(x) decreasing? So if we differentiate that, you get minus 1 minus 4x. So if you put in x equals 1, now notice why I wrote this out. Look, instead of writing x equals minus 1, I just put the minus 1 in the brackets for the x. So that's just a neater way of writing it. So put minus 1 in, you get 3, so it's increasing. Part B is put in x be 0. So it gives you minus 1, so it's decreasing. And so on. X is 1 and x is 2. So just a neater way of writing it. Number 2, you're looking to see which of these when it is an increasing. So differentiate it. It's increasing when it's greater than 0. Now if you notice there, when you differentiate it and put it greater than 0, everything can be divided by 3. You can only do that if you've got a 0 on the other side. So I can do that this time. Just makes it a wee bit easier. So I can factorise it. Critical values, draw out your graph, 1 and 3. I want above the x-axis, so this side of the graph and this side of the graph. Number 3, a curve has got this equation, find the turning points. So differentiate, turning points, differentiate it, put it equal to 0. So again, like you said, divide by 6, so dividing everything there by 6, you get those critical values. Turning points, when you got your x's, work out your y's, just as normal. And then to find if it's maximum and minimum, differentiate again and sub in your x values. So sub in minus 2 for this one. It was under 0, so it's maximum. Sub in 1 for this one. It's above 0, it's a minimum. Number 4, which of these are the turning points? So I wouldn't read the options for the answers. I would start with the y, differentiate it. Turning point is you differentiate it, put it equals 0. Get your x values out. You've got 2 x's. Remember, when you're doing the square root of 1, the answer is plus or minus the square root of 1, which is plus or minus 1. So when x is 1, work out your y. When x is minus 1, work out your y. To find if it's maximum and minimum, do your second derivative. So where's my second derivative? So when x is 1, it works out to be a maximum. And when x is minus 1, that works out to be 6, which is a minimum. Number 5, this is just it's looking for the largest value. It's looking for the maximum value. So instead of having y, you've got I. Instead of getting x's, you've got t's. So you just differentiate di by dt. Differentiate is normal. It's maximum when it equals 0. So set that equals 0, dividing by 3 to make it easier, factorising it, finding the t values. And always check if it's maximum or minimum. To do that, the easiest way, second derivative, so differentiate this again, sub in your 3, and it works out to be above 0, so it's minimum. Sub in your 1, works out to be beneath 1, so it's a maximum. So the question wants to when it's a maximum, so I'm choosing this value, and t is 1. To work out what the I value is, just sub the 1 in to your I value at the very start. And number 6 is onto these graphs, which is a little bit more awkward, but we'll just take our time with this and see how we get on. So I've drawn out the first graph. It turns here and it turns here. So that's when the gradient is 0. So make sure you got your 2 turning points on. One on the positive or the negative x-axis and one's on the positive x-axis. Before this turning point is increasing, so it's positive. Between the turning points, it's decreasing, so it's under the x-axis. After this turning point, it's increasing, so it's above the x-axis. Now, part B, or graph B. So if you draw out the graph B, it turns here on the negative x-axis and it turns here on the positive x-axis. Before the turning point, it's going down, so it's a negative gradient, Between the 2 turning points, it's going up, so it's positive. So it has to be between these 2 points above the x-axis. Other side of this is decreasing, so it must be beneath the axis. Graph C, it turns up here, so the turning point, when you put it over the gradient function, is on the x-axis, because that's turning point, the gradient is 0. Before the turning point, it's going up, so it has to be in the positive x-axis. After the turning point, it's going down, so it needs to be beneath the x-axis. This is constant, so the gradient doesn't change, which is a flat line. But it's a negative gradient, so the gradient is going to be beneath the x-axis. This is constant gradient, it's not changing, it's positive, so the constant line is going to be above the x-axis. If you're not getting those gradient functions, don't worry too much about them. Just see how you can fiddle about with them, and we'll worry about that when we get back to school.